Welcome to this Blue Pearl software video. I'm Emma Molyneux, Sales Director for North America. Over the next few minutes, we will look at a couple of customer case studies that highlight the benefits of using Blue Pearl's visual verification suite for advanced linting and debug, clock domain crossing analysis, and automatic SDC constraint generation for creating and delivering high reliability RTL. Specifically, I'll be walking you through one from Northwest Logic, who leverages our advanced linting for ASIC, FPGA, and IP development, and the other from IT Dev, who leverage both our linting and clock domain crossing analysis of the visual verification suite to eliminate metastability issues in their FPGA designs. Before we walk through them, for those of you not already familiar with Blue Pearl software, let me tell you a little about who we are and what we offer. We are a leading provider of verification solutions for ASIC, FPGA, and IP. Our users are RTL developers and verification teams in military and aerospace, semiconductor, medical, and communication industries who wish to avoid costly and time-consuming design respins due to simulation versus hardware mismatches, invalid constraints, and clocking issues. Blue Pearl's visual verification suite complements RTL simulation solutions provided by EDA and FPGA vendors. We ensure your code is highly reliable with advanced linting and debug, clock domain crossing analysis, and automatic SDC constraint generation. We streamline the verification process with built-in FPGA libraries and our all-new project import from Intel Quartus and Xilinx Vivado Design Suite, along with ASIC libraries and third-party tool project imports. Verify as your code instead of waiting for simulation, synthesis, and place and route. Or worst of all, finding issues in the lab where they can be very difficult to debug. The integrated environment is designed to quickly find and fix all of the following stated issues in the slide that you can see. And on the way to tape out or final bitstream generation, our management dashboard provides easy tracking of the quality of the design based on required checks. It's also ideal for reporting during design reviews and audits. Okay, let's move on and look at how design teams like yours leverage our solution to accelerate development while ensuring quality. The first case study we're looking at is Northwest Logic. Northwest Logic are a premier provider of to-the-point for PCIe memory interfaces as well as MIPI solutions. By to-the-point, they mean each core is configured to their customer's specific point use case, target device, and technical requirements. This can result in many derivative cores generated from one master core, with each derivative requiring verification to ensure quality. As an IP provider, their main objective is providing a quality solution. The key to Northwest Logic's success has been providing high quality, high performance, and easy to use IP to their customers. They do this with a combination of good coding practices such as fully synchronous design, proper handling of clocks, resets, RAMs, etc., and strive to design for easy timing closure, which is very important as the same core may be implemented in an FPGA, structured ASIC, and ASIC. While Northwest Logic does do full simulation and hardware validation, by doing RTL analysis upfront they save time, improve overall efficiency, and ensure that no issues slip in during updates to the master cores or when customizing one for a customer's specific use. For example, the Northwest Logic Espresso 4.0 PCIe core is very configurable, with 20 defines, 50 parameters, and 200 control registers. Their cores must work across multiple platforms and operating conditions. This means with one core they can produce hundreds of to-the-point variants, and each is required to be of the highest quality, highest possible performance, and work on all platforms. Northwest Logic has integrated our visual verification suite's Analyze RTL into their environment. They leverage the Tickle interface to complete hundreds of verification runs per week to verify all the cores' check-ins and end customer cores before they are delivered. When an issue is reported, they then leverage the easy-to-use integrated debug environment with its numerous views such as FSM, longest path, to quickly find and fix the issue before any downstream tool has been run. It is all about maintaining a quality source database and ensuring their end customer deliverables work as promised and minimizing full chip linting issues. One feature of the visual verification suite that Northwest Logic rely on is the ability to enforce their own coding standards and best practices. This has been very valuable as they bring in new developers. The bottom line for Northwest Logic is ensuring issues are found and eliminated early in the design cycle and not found by their end customers. They do this by continuously verifying. Now let's look at IT Dev, a major supplier of FPGA and embedded services. IT Dev has experience from the IP block level through to full multi-device architectures and specialize in video and Linux-based systems. They are a company that understands the value of streamlined development flows that move verification to the forefront of the design, as well as understand that the FPGA development tools provided by the vendors are focused on synthesis and place and route, and do not provide all the verification tools required to find issues up front where they are the least costly to address. If you are interested, you can read more about their overall design flow in their white paper, Is Your FPGA Design Flow Optimal? As a design services company, they deal with customer-developed code, third-party encrypted IP, as well as internally developed code, and must put together a completed design that is highly reliable. While they leverage the Visual Verification Suite's RTL analysis for advanced linting, they also take advantage of the clock domain crossing analysis to ensure, as they assemble the design, metastability issues don't creep in. Clocking issues can be difficult to find and debug, and they are very difficult to reproduce and debug if found during lab testing. For IT Dev, reliability issues can cause a support burden and, even worse, expensive field returns, so a solution to address them is imperative. IT Dev understands the need for CDC. The tool lets them quickly find and fix CDC synchronization issues that can be missed by FPGA tools. For example, with Intel Quartus, where the MTBF reports synchronized clock domains but fails to report on unsynchronized domains. With the reports and schematic views, they can easily see what is good to go and what needs to be worked on to ensure all clock domain crossings are synchronized. There are several solutions that IT Dev could have adopted, but they chose Blue Pearl, partly because of our advanced clock environment. One of their challenges is to understand existing clocking from customer and third-party IP. ACE enables them to evaluate clock domains, SDC clock constraints, and view the results graphically and generate missing SDC constraints. This is great if you have the RTL, but what happens when the design contains encrypted IP, like that provided by the FPGA vendors and third parties? This is where our patent pending using gray cells come in. The user gray cell is a simple XML file that can be developed with just the core's datasheet and enables CDC analysis across the entire chip. We work closely with the FPGA vendors and have built-in library support, so in most cases the gray cells are already built into the tool for the FPGA vendor IP. But for third-party or new vendor IP, it is nice to know you have the ability to verify without access to the source code. IT Dev has built their FPGA development flow to optimize their development time while delivering quality designs to their end customers, and our Visual Verification Suite is critical to their development, saving them and their end customers time and money and giving them the peace of mind that the end deliverable is of the highest quality. I hope over these last few minutes you have heard how companies like yours can take advantage of Blue Pearl's Visual Verification Suite to accelerate your RTL development, improve quality and reduce risk. Thank you for your time. Please visit us at www.bluepearlsoftware.com.